Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5. It says a roller coaster car of mass 200 kg with an engine switched off travels along track ABC, which has a rough surface as shown in the diagram below. At point A, which is 10 meters above the ground, the speed of the car is 4 meters per second. At point B, which is at a height of h above the ground, the speed of the car is 2 meters per second. During the motion from point A to point B, 3.40 times 10 to the exponent of 3 joules of energy is used to overcome friction. Right, so note that 3.40 times 10 to the exponent of 3 joules of energy is used to overcome friction. This is the work done to overcome friction. Then it says ignore rotational effects due to the wheels of the car. Then 5.1 says define the term non-conservative force. So quickly, we just say non-conservative force is a force for which the work done in moving an object between 2 points depends on the path taken. That's how we are supposed to define a non-conservative force according to the CAPS document. Right. Then 5.2 says calculate the change in the kinetic energy of the car after it has traveled from point A to point B. And that is only for 3 marks. So we know with a 3-mark question, it's just the formula, substitution into that formula, and then the correct answer. So we have change in EK is equals to half mvf squared minus vi squared. And then this is going to be half. Our mass is 200. And then our V finally at point B, that's 2, and then square that. And then we have our V initial at point A is 4, then square. When you punch all this into your calculator, it gives you negative 1,200 joules. And then you are supposed to leave it as a negative like that. So you do not interpret anything here. You just simply leave it as a negative. It is correct to get your energy as a negative, guys. Then 5.3 says use energy principles to calculate the height h, right? Then now looking at this, we are looking for the height h. And then from reading, we can see that here there is frictional force because we are even told of the energy to overcome the friction, which is the work done to overcome friction. So this in a way is screaming to us that the formula that would be of much use in this question would be the formula for work done by non-conservative force, mainly because we are looking for the height, and then we said that formula works best if we are looking for the height, and then we are also given another relative height, and then also if they mention any non-conservative force there. So because we can see the hints were dropped there, they made us define the non-conservative force. Friction is a non-conservative force, and they also gave us the work done to overcome friction. So that alone is screaming to us. It is the hint by the examiner to say use this energy principle here, work done by non-conservative force. So pay attention to those hints, guys. Then that's equals to change in P plus change in EK. Right. Now at this point, what is our work done by non-conservative force? It will be represented by the work done by Fk, right? Or the work done to overcome friction. Then we can break down this formula. That's mg, height finally minus height initially, plus half mvf squared minus vi squared. Now, some people write this one as change in EK plus change in EP. That is basically the same thing, guys. It is not different. It's just the same as saying 1 plus 2 or 2 plus 1. It's basically the same thing. Then work done by Fk. Now, there's something that we must consider. If we are saying this is the work done to overcome friction, then the way we represent our work done by Fk here is that we need to substitute this as a negative, because remember, anything associated with kinetic frictional force goes in the opposite direction of the displacement. And if something goes in the opposite direction of displacement, it has cos 180 degrees, which gives us -1, which means the whole work done will end up being negative. So that needs to be substituted as -3.40 times 10 to the exponent of 3. Right. Then what is our mass? It's 200 kg. And then our gravitational acceleration 9.8. Then height finally. The final height when it reaches point B is h. That's what we are looking for. But then the initial height at point A is 10. Right. Then here we have half and then 200. Then the final height. Now at this point, what we can do to just cut off all this, we can just look at this. Note that in 5.2, we had already calculated the change in EK. And then it's basically the same thing that we are going to substitute in here. So we can just replace this by -1,200. Right. So, and then now we have plus times negative. That's going to be -1,200. Right. So because all that I'm going to substitute here is basically what I've already did in 5.2. So I'm just going to substitute the value as it is. Okay. So now we have -3.40 times 10 to the exponent of 3. And then when we multiply 200 times 9.8 times h, we get 1,960 h. And then 200 times 9.8 multiplied by 10, that's 19,600, then minus 1,200. Now at this point, we can see that we are supposed to just take all of this and transpose it over to the left-hand side. So we will have -3.40 times 10 to the exponent of 3 plus 19,600 and then plus 1,200. So this side here, we are left with 1,960 h. Now, when we punch all this into our calculator, we get 17,400, and then that is equals to 1,960 h. Then to get our value for h, we obviously need to divide by 1,960 both sides. Then our height is going to be 8.88 meters, rounded off to 2 decimal places as per instruction of the exam. Right. Then this is how we would have calculated our 5.3 there. Now, let's go to 5.4. So it says, we have a statement there that says, on reaching point B, so when the trolley or the car is now at point B, on reaching point B, the car's engine is switched on in order to move up the incline to point C, which is 22 meters above the ground. While moving from point B to point C, the car travels for 15 seconds at a constant speed of 2 meters per second. Travels for 15 seconds at a constant speed of 2 meters per second. Why are we given this? If you can check here, this is to make up for the fact that we don't have the displacement as the car is moving up the incline. But then remember, we know that according to DST, which is a formula that you were using in grade 8, grade 9, to find the distance, you actually say speed multiplied by time. So in order to find our delta x, according to this, we're just going to say the velocity, the constant velocity, multiplied by the change in time. So our constant velocity, we are given 2 meters per second, then our delta time is 15. So this is going to give us 30 meters. So that means the displacement here is 30 meters, right? Then at this point, what are we looking for? It says, while an average frictional force of 50 newtons acts on it, calculate the power delivered by the engine to move the car from point B to point C. So we are calculating the power, right? So power has the formula P is equals to W over change in T, or this one P is equals to F times V average, right? Now, if we are to use this formula, then you can see that we must find the work done by the engine, then divide it by the time that we are given. But if we are to use this formula, then we have to use Newton's second law in order to find the net force, and then multiply it with the average velocity that we are given. Our average velocity is 2 meters per second, right? So now, because we are dealing with work and I'm interested in showing you the more use of the work in the WNC formula or the energy principles, let's just go with this one, right? So let's first calculate the work done by the engine. Now you would notice that the engine is also some kind of an applied force, right? Remember, engine is an applied force, and then we said an applied force falls also under non-conservative forces, right? So we can still use the formula WNC is equals to change in EP plus change in EK, right? But then the fact that they mentioned here that this is moving at constant speed, right? Now, this is a keyword in physical science to say that whenever you see constant speed, this simply tells you that your acceleration is 0 meters per second square, your F net is 0 newtons, your W net as a result becomes 0 joules. And then since we know that our W net is equals to the change in kinetic energy, then even our change in kinetic energy becomes 0 joules. So that means using this formula here, we have to consider that our change in EK here will have to be 0 joules as a result of the car moving at constant speed, right? So, but then to break down our work done by non-conservative forces, now at this point, we now have two non-conservative forces, which is the force applied in the form of the engine, and then the frictional force that will be opposing the motion of the object. So now we'll be saying work done by the force of the engine plus the work done by the kinetic frictional force. So these are our two non-conservative forces, right? Then this will be mg, height finally minus height initially, plus 0. Right. Remember, the 0 is coming from constant speed. Now we are looking for the work done by the engine. So let's just break down the Fk here. That's Fk delta x cos theta is equals to my mass is 200, then multiplied by 9.8. Height finally, that's the height at point C, is 22, then minus height initially, that's the height at point B, which we did calculate, it's 8.88 from the previous question, right? And then now at this point, we can say work done by the force of the engine. Then let's substitute our Fk, we had 50, and then our delta x we calculated here is 30. Then cos, this is supposed to be 180 degrees because we know the kinetic frictional force will always oppose the direction of the displacement, right? Then when we do the calculation for this one, we have 25,715.2 joules, right? Then having to calculate here, we have work done by the force of the engine. And then here, this is going to give us 1,500. If we multiply here, then is equals to 25,715.2. Then let's take the negative 1,500 and transpose it over to that side. If we transpose it, it's going to add to that and then give us 27,215.2 joules, right? Now, if we have the work done by the force of the engine, now we can calculate the power delivered by the engine because we already have the work done by the engine. And what is power? Power is the rate at which work is done or energy is dissipated. So that means at this point now, I can now come here and say this is power of the engine is equals to work done by the force of the engine over the delta time, right? Then now we have 27,215.2 over 15, which is the time that we were given here, 15 seconds, right? Then having to punch that in your calculator, that's 1,814.35. And then remember the SI unit for power is watts, right? And then just like that, you have completed your question for 5 marks. So always bear in mind that most of the 5-mark questions involve you having to use more than one formula. So you are looking for the power, but then you soon realize that you do not have the work done by the engine. So what do you do first? You start calculating the work done by the force of the engine, and then you can come back and use the formula to get the power. So that's how most of the 5-mark questions are actually structured. You deal with more than one formula. Okay, so with all that being said, guys, please press the thumbs up button if you've enjoyed the lesson and then you've found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.